All right, so today we're going to do a little review of fractions, stuff that you definitely talked about in sixth grade. So this is lesson 0-1, 0 for unit 0, because this is a unit 0 on review. So unit 0 is review. And this is lesson 1, fractions review. So we have the top and we have the bottom of a fraction. There's two parts to it, the top and the bottom. The top of the fraction has a name that starts with an N, and the bottom has a name that starts with a D. Maybe you remember those from last year. The top is called your numerator, and the bottom of the fraction is the denominator, D-E-N-O-M-I-N. I have to spell it out, otherwise I spell it wrong every time. So let's go ahead, and if you haven't already, start listing some examples of some fractions. Some examples of fractions that I can think of are, 1/2. I don't know why that one's so bold. Or maybe a number that looks like this. I don't remember what that number is called when it's got 4 and a half, when it's got a big number and a fraction. That is what's called a mixed number. And that's okay because that's still a fraction. Or what about something that looks like this? What if I have 10 over 3? Remember the name of that fraction? Remember what that kind of fraction is called? When the top is bigger than the bottom, that is what's called an improper fraction. And then naturally there's going to be a whole bunch of other different types of fractions that we'll look at as well. We're going to get into talking about positive and negative fractions, so maybe negative 2/3. And what about this guy? What about if I gave you something like 16 over 2? Or actually, why don't we just make it even simpler? Why don't we do 16 over 1? That's still a fraction, even though that's just equal to 16, because I can still put it over 1. It's still a fraction. All right, so now let's take a look at adding and subtracting fractions. So the most important thing that you need to remember is that when you are adding and subtracting fractions, you must have common denominators. The denominators, or the bottoms of the fractions, have to be the same in order for you to be able to add and subtract them. So in our first example here, example 1, we have 2/3 plus 7/8. I have a 3 in the denominator and an 8 in the denominator. Neither of those are the same. So to get common denominators, we're going to use those LCMs, or those least common multiples. I'm going to do this first one in depth a little bit, and then the next ones we'll use some shortcuts. So if I start with 8, I've got 8. 8 times 2 is 16. I'm just listing my multiples. 8 times 3 is 24. 8 times 4 is 32, and I'm going to stop there. And I'm going to start with my 3's. 3 times 1 is 3, 6, 9, 12, 15, 18, 21, 24 finally. So it looks like 24 is the least common multiple I'm going to use for my common denominator. So when you're doing this work and you're showing me and you're getting those common denominators, you just need to show me what you're going to multiply each fraction by. So over here, if I'm trying to turn 3 into a 24, I need to multiply that by 8. And I'm just going to show that by putting a little dot, 8. Whatever I do to the top or to the bottom of my fraction, I need to make sure I do that to both so I keep it equal. So 8 times 2 on the top gives me 16. 8 times 3 on the bottom gives me 24. Now, for my other fraction, I'm trying to turn that 8 into a 24, which I'm going to do by multiplying by 3. So top and the bottom by 3. 7 times 3 on the top gives me 21. 8 times 3 on the bottom gives me that 24. So now that I have my common denominators, I can go ahead and add my fractions together. So I've got the 16 24ths plus 21 24ths. Maybe you need to do this off to the side like I do, or maybe you can math that in your head, for a total of 37 24ths. Or you can turn that into the improper fraction, the mixed number, 1 and, let's see, 27 minus 34 is 13. So 1 and 13 24ths. Either of those answers would be acceptable. Okay, so that was our adding answer, or adding example. Let's take a look at a subtracting example. So here I'm still adding and subtracting fractions, so I still need to make sure I have common denominators, which I do not. Instead of going through and listing out my multiples, which is totally fine if you want to, I'm just going to know that 7 times 2 is 14, so I'm going to multiply 7 times 2, and I'm going to multiply my other fraction by 7. Notice how I'm multiplying by both the same thing on the top and the bottom. 2 and 2, 7 and 7. So 6 times 2 gives me 12. 7 times 2 is 14. Carry down my minus sign. 1 times 7 is 7. 7 times 2 is 14. So 12 14ths minus 7 14ths, which is 12 minus 7, which is 5, 7, 8, 9, 10, 11, 12. I'm just double checking myself. So final answer for example 2, 5 14ths. So there we have our adding and subtracting. Next, we're going to take a look into multiplying fractions. And when you're looking at multiplying fractions, you want to make your life a little bit easier by checking for some cross-canceling. So when you're multiplying fractions, you're going to multiply straight across. So what I mean by that is that you're multiplying tops by tops and bottoms by bottoms, or denominators by denominators, numerators by numerators, denominators by denominators. When you're doing this, though, you also want to keep out and you want to look to see if you can check for what's called cross-canceling. And I'll show you that in a second. So first, if I were just to look at this problem, this example 3, and multiply straight across like it tells me, I'm multiplying 9 times 5 to get 45, and 7 times 3 to get 21. But now this answer can be simplified, right? There's something that goes into both 45 and 21 that we can reduce by, and that would be 3. "45 divided by 3 leaves me with 15, and 21 divided by 3 leaves me with 7. So 15 sevenths, or 1 and, actually, no, sorry, 15 is not 1. Obviously, I can put 2 in there. 2 and 1 sevenths. So now, I want to go back and I want to talk about that cross-canceling. We're going to look at the same problem again, but this time we're going to look at what can happen if we do cross-canceling. So cross-canceling is canceling like an X. So they have to be diagonal. When you're cross-canceling, they must be diagonal from each other. Must be diagonal. So I could see if I could cancel the 7 and the 5. is there anything that goes into both 7 and 5 evenly that I could cancel out? And the answer to that is no. Nothing goes into 7 and 5 evenly. But however, something does go into both 9 and 3 evenly, and that would be 3. So I could quickly cancel out each of these pieces and divide them by 3. So that my 3 divided by 3 turns into a 1, and my 9 divided by 3 turns into a 3. So now I'm just going to take a second and rewrite that. I have 3/7 being multiplied by 5 over 1. Now that I did that cross-canceling, I can go ahead and multiply straight across like we did in the above example. 5 times 3 is 15. 7 times 1 is 7. Leaving me with that 15/7 that we got above, which is the same as that 2 and 1/7. So either way, just the cross-canceling has you do the simplifying in the beginning, whereas over here in our first way that we did this, we did the simplifying at the end with those divide by 3s. All right, so if you want to take a moment and pause this video and try some practice problems on multiplication, you are more than welcome to do that and come back to this later. If not, we are going to go ahead and move on to reviewing dividing fractions. So when you're dividing fractions, you might have an acronym in mind, some kind of keep, flip, change, or keep, change, flip, which is all good and handy. Those are great acronyms to use, but they're not real life math. The real life math words that come from, keep, change, flip, or when you're dividing fractions, those are what's called you're multiplying by the reciprocal, reciprocal, reciprocal. This is what your keep, change, flip really means, keep, change, flip really is just multiplying by the reciprocal. Multiplying by the reciprocal is the real life math for that. So we'll take a look at some examples. In our first example 4 here, they're taking a whole number and they want us to divide it by 1/2. Remember, I can very easily turn any whole number into a fraction by putting it under or over 1. So I can change 5 into a fraction by saying 5 divided by 1, or 5 over 1. So now I'm going to multiply by the reciprocal, or do that keep, change, flip. So I'm keeping the first fraction the same, multiplying, instead of doing division, I'm using multiplying. And the reciprocal, remember reciprocal, if you are unfamiliar with that word, reciprocal just means flip your fraction. So instead of using 1/2, I'm going to flip that. I'm going to take the reciprocal of that and use 2 over 1. 5 times 2 is 10. 1 times 1 is 1, which gives me 10. And I'm just going to show you a really quick visual of why it makes sense that we started with something smaller and then we divided it and we ended up with something bigger. And that's here because we're taking 5 things and we're splitting them in half. We're giving ourselves more of those. So I'm going to show you a little diagram that you should draw. If I start with 5 things or 5 boxes, I've got 5 things right there, right? But if I go through and I divide each one in half, you'll see now that I'm not left with 5 things. I'm left with 10 things. So that's kind of why when we're taking a whole number and dividing it by a fraction, we end up with a larger number, when in most cases you're used to ending up with a smaller number when you divide. Let's take a look at another example. So example 5 says 4/9 divided by 2/3. So I'm dividing, which means I need to be multiplying by the reciprocal. So multiplying by the reciprocal means that I keep that first fraction the same, 4/9. Division changes to multiplication. And we are going to start using that dot for multiplication instead of the x. So try and stay away from using that x. And I'm using the reciprocal of 2/3, or I'm flipping 2/3 to make that 3/2 instead. So now I've got my multiplication problem set up, and just scrolling back for a second, reminding myself that when I'm multiplying fractions, I can check for cross-canceling, and I'm multiplying straight across. So, can I cross-cancel diagonally anything with the 4 and the 2? I would say yes. I think 2 can go into 2, and 2 can also go into 4. So when I simplify that, my 4 is going to change to a 2, and my 2 is going to change to a 1. Also, though, I can do a little cross-canceling with the 9 and the 3. Both of those are evenly or equally divisible by 3. So if I divide 9 by 3, that gives me 3. Dividing 3 by 3 gives me 1. So you can see this kind of looks like a hot mess right now, all these cancelings and whatnot. So I'm going to take the quick second, to rewrite that with my new numbers. So I now have 2/3 times 1 over 1, which very nicely gives me just plain old 2/3. And so again, real quick, if you're good here, you can shut this video off and you can move on to the practice problems. But if you didn't think about the cross-canceling, remember, you can just multiply straight across. You would just have to do some simplifying at the end. So 4 times 3 is 12, 9 times 2 is 18. I know that both 18 and 12 are divisible by 2. So if I divide by 2, I wish that one wasn't so... Let's try divide by 2, divide by 2, 12 divided by 2 is 6, 18 divided by 2 is 9. But look, I still have 6 and 9, and those can still be simplified further. Divide by 3 gives me that 2/3 that we also got above. So just keep in mind that if you don't do the cross-canceling in the beginning, that's fine. You just might have to do some simplifying towards the end. All right, congratulations. You made it through your first day of notes.